This is my BV20 lathe. It's came with just the normal right hand screw threading, which is a bit of a pain because I want to actually redo this crappy hand wheel into something more useful with better divisions and somewhat clearer scales to read. I don't know if you get a good shot of that. They're pretty ordinary scales, something like 0.04 millimeters per tick on there. And they're, yeah, it's quite a frustrating measurement, the 0.04 millimeters. But of course, inside here, we have a left-hand lead screw, and I really need to cut a new lead screw so I've got a better mounting arrangement for the hand wheel. So in the back end of the lathe here, I've actually built a new banjo, which is where all the change gears fit on. Most of these change gears I've actually had to fit up myself, as none were supplied with the lathe other than a standard set for doing a bit of fine feed. Certainly not the full set required as indicated on the threading chart on the side here. So if you look closely in here, centre stage there is the new idler wheel, which provides a reversal of rotation on the lead screw. Nestled behind there is the normal set of gears. So comes out of the spindle geared down drive there, through that reversing gear to the first gear, which is a compound with the larger aluminium one there, final drive to a lead screw. And this is all set up to do 2mm pitch at the moment, which is what my lead screw requires. So let's just do a little bit of a test run. Got the speed wound right down, hit the go button, lathe rotating in normal forward direction, engage the feed, there we go, moving across to the right. The original banjo looked like this, the cast iron affair, so I've modelled most of that into the new design. If you stand by, I'll remove the other banjo to see where everything changes. Okay, banjo's taken away, as you can see, which have a look down here. Here's the new banjo. If you compare that to the old one, you can see they're much the same. I've actually increased the sweep of that angle there, so it gives you more scope for adjustment, especially considering we need to swing down below the main change gears. Here's the idler wheel, which is mounted on a ball bearing, and this is the normal shaft. Whoops, let's zoom that back out, silly phone, which is where the normal compounded gears would fit onto and engage, as it has just down there. With the reverse tumbler. Now of course, if we don't want to cut left hand gears, it's just a case of either removing this entirely or disengaging it so we can actually mesh up with a normal gear. I'll use the original banjo as a demonstration. So that just normally would swing up to engage the cogs from there across to the lead screw. Anyway, that's my shiny new banjo, all built out of 16mm steel plate. Okay, I've installed the new banjo now without the reverse tumbler gear installed. You can just see the T-nut still living within the slot. The reverse tumbler's just here. I just Loctited it on because it wasn't actually Loctited before, I just discovered. So that's just on the bearing with a spacer Now space is important because it needs to reside. Light's a bit horrible here. Here we go. It needs to engage with this outside gear, which actually turns 10 times faster than the inside gear here. The inside gear is used for normal fine feeding purposes. So I've got it set up here at the moment. It will actually go 0.04 millimeters per revolution of the chuck, as indicated here. You've got a 70 tooth and a 105 tooth, which I don't know if you make it out. There's 105 stamped on this one, and that one's a 70. You just have to understand it's a 70. So of course, without the idler, everything rotates in the normal fashion. And of course, we normally turn the handwheel this way to go towards the chuck. Now turn the fine feed on. There you see it's normal right hand rotation, so that's what you'd use for right hand screw cutting. So there you go. It works in the conventional manner, and I can slot in that extra sprocket and swing it down a bit further to do left hand gear cutting. Oh sorry, screw cutting.